Let's start in San Francisco. The Golden Gate Bridge is one of the most famous bridges in the world. Unlike other bridges which uses arches and beams as support, the Golden Gate Bridge uses cables that suspend it above the water, carrying its weight. To understand this phenomenon, we need to explore it in two different dimensions, a one-dimensional situation and a two-dimensional situation. Tug of war is a great way to explain tension in a one-dimensional manner, since it functions only on one axis, the x-axis. Let's start with a simple equation that's in equilibrium. In this situation, we see both sides pulling the rope with 100 newtons. The green team is pulling with 100 newtons and the red team is. The tension of both of them is 100 newtons. It's equilibrium because it cancels out both forces. The force of tension cancels out the force of 1 and 2. Tension is a great example of Newton's third law. For every action, there is an equal and opposite reaction. Newton's third law shows that there are force pairs. Basically, the size of the forces on the first object equals the size of the force on the second object. Let's change the situation. Let's say force 2 acts with 250 newtons instead of 100 newtons. What would be the force of tension? The force of tension is still 100 newtons. As long as force 1 acts with 100 newtons, tension cannot be greater than that. The leftover force from force 2 is represented by an acceleration in that direction. Now that we've seen tension in a one-dimensional example, let's see it in a two-dimensional situation. When we diagram the situation, force of tension leans at some angle pointing upward, while the weight of the wrecking ball aims directly downward. We can factor force of tension into an x component and a y component. Because we know that the wrecking ball is swinging rightward, force of tension in the y dimension must cancel out force of gravity, which means that the net force of this problem is equal to the force of tension in the x direction. The Tacoma's Narrow Bridge is one of the most famous bridge collapses in history. There, the cables snapped when there was too much tension in the cables. In the video, we see three forces acting on the bridge: force of gravity, the force of tension in the cables, and the force of the wind, which causes the up and down motion. This up and down motion, also called oscillatory force, makes tension on one side of the bridge greater than the other. As the effect from the oscillatory force becomes stronger, the tension in the cables build until they snap and the bridge collapses.
No structure of steel and concrete can stand such a strain. Steel girders buckle and giant cables snap like puny threads. There it goes! Engineers are divided as to the cause of the disaster. Some claim it was the use of solid girders. Others differ. But whatever the reason, Tacoma will rebuild. This time a bridge that will not provide a super thrill in the news.
Whenever zipline attractions open, they have to perform tension tests. When people slide down the zipline, the tension on both sides of the zipline change. The total tension does not change, but the ones on both sides do. So, for these attractions to remain open, they have to perform these tests in order to remain successful.